In this video, we're going to learn how to find the eigenvalues of a matrix. So remember, the key idea of a value being an eigenvalue is that we're scaling a vector when we do a multiplication. So in other words, lambda is an eigenvalue if ax equals lambda x for some non-zero x. And another way of interpreting that is that if we subtract the lambda x over to the other side and factor out that if we do a minus lambda I times x equals 0 for some non-zero x. So in other words, what we're doing is we're looking for a non-zero element of the kernel of a minus lambda I. For a square matrix, we know that the kernel is going to be non-trivial exactly when a minus lambda I is not invertible. And one way to see that a minus lambda I is not invertible is to look at its determinant. We know an invertible matrix has to have a non-zero determinant, and if our determinant is 0, we're not invertible. So our technique for finding the eigenvalues is to compute the determinant of a minus lambda I and figure out what values of lambda make it equal to 0. So let's look at this with our particular a here. First thing we'll want to do is write down a minus lambda times the identity. So this is 3, 7, 2, negative 2. We'll subtract off lambda times the identity. Well, we multiply our 1, 0, 0, 1 by lambda, so we get lambda 0, 0, lambda. So in other words, we have 3 minus lambda, 7, 2, and negative 2 minus lambda. So to compute the determinant of a minus lambda I, we're now doing the determinant of a 2 by 2 matrix. So we'll multiply our diagonal entries, negative 2 minus lambda here. We'll subtract off 2 times 7, our anti-diagonal entries. So now we just need to do a little bit of manipulation and then find the roots of this polynomial, which is quadratic in lambda. So if I expand this out, it looks like I have a lambda squared, and then minus lambda, and minus 6, and minus 14 from the 2 times 7. Got lambda squared minus lambda minus 20. And now to find the roots, we can just factor. Looks like lambda minus 5 times lambda plus 4 will do the trick. So lambda equals 5 and negative 4 are the roots of this polynomial. So they are the eigenvalues of our matrix.